Okay, so we will still be solving. We're going to evaluate the logs. For your warm-up, please do A through D without a calculator, because that would be something we would ask you to do without one. So take a minute, not even, to do A through D. You've done this on the quiz. You've done this on the last chapter's test. Remember, this is kind of give you a hint. If you forgot, that's when we did 2 to what power gets me 4. Just take a minute, not even, and finish those problems. You can't get D, can you?
That's why
Yeah.
I think that's supposed to be.
Yeah. All right, so then hopefully you got here, and maybe in your brain or with the group member, you're like, man, how did you get D? Okay, D is tricky for a reason, because this is why we're getting into it. If we don't know the solution, there is 3 to no power that gets us 18, we can actually figure it out. So which log above did we have trouble with? We had trouble with D. And that's just because, again, there's no way to find 3 to what power gives me 18 from what we know. But we are going to learn something today called the change of base formula. Some of you have really fancy calculators. Some of you don't have such fancy calculators. And I'll show you both ways. It's always good to know that another option in case you don't have your fancy calculator on you. Some logs are not as easy to evaluate as the above, and we will require the change of base formula. So the change of base formula is just that log of the argument divided by log of the base. Remember, log is just a base of 10, which is what your calculator has. 90% of all of them have that. It's just some of them you can do a trick with it. So we're going to use that change of base formula to try to do the one that we couldn't solve. So with your calculator, I'm going to show you the normal way first, and I'll show you the trick if you have a fancy calculator. So let me get mine out. We're going to press that log button here in red. And the argument. The argument was 18 divided by log of the base. And our base was 3. Press enter, and we get 2.63 something. That is the solution. That's what the answer is. It's going to get you somewhat of an answer. It's not going to be 100% accurate, but it's very, very, very close. So 2.63 is what I'm going to write down for my answer here. So I want you to go ahead and try the rest of them out. Actually, no, let me show you the trick for that one before I do that. Because some of you do have a fancy calculator. If you press math, if you have a fancy calculator, and you scroll down, and I think it's option A here. Oop, I pressed too many buttons. If you press math and you see that log base, that option A here. If you go ahead and click that, if you have it, you can now just type it in. If you have that type of calculator. If you don't, you'll have to do the change of base formula. Either one is easy. And you'll see here that you can just type that in, and you're going to get the same answer as what we got. Okay, so go ahead and try the rest of them. Either one works. Just getting familiar with your calculator, please go ahead and do the rest of them. If you need help, please ask us. Now's the time. I'm going to steal your key, Miss M. .21 divided by 2. Don't know that in my head. Yeah. Hopefully you got these answers. If you didn't, raise your hand and we'll show you where you went wrong in your calculator. I would get used to using the change of base formula just in case for whatever reason you don't have the calculator that you normally work with, especially if you borrow them. Okay, if you borrow them, some calculators are a lot different. What if you get stuck with a different one? Okay, always use the change of base formula unless you know that that's my calculator, that's what I'm always going to use, and go ahead and use that trick if you need to. Okay, questions? Easy, right? This applies to our work in solving exponential equations. If you can't write each side of the equation, use the same base. So if there's no way to write the same base, we're going to have to use the change of base formula. And there are a couple steps. The first step is to isolate the exponential expression. What does isolate mean? Get it by itself. A lot of people struggle with that part on the quiz, where you guys just left it there and converted with that 5 all the way out in front on the quiz with the logs. But now we're going to be talking about exponential. So that base needs to be isolated. That b to the x power needs to be isolated. Take the log of both sides. That's the way I learned it in high school, take the log of both sides. However, I like the wording better. I'm just going to kind of go off to the side and put convert to exponential. It's basically the same thing as taking the log of both sides. Okay. You cross that out and put that. All right, so 3 would be you need to expand the log using the power rule. You may need to, not always. And then 4 is solve or check for extraneous solutions. Whenever we are working with logs, you might have extraneous solutions because you can't have what in the argument? A negative number. Very good. Okay, so round your answers. It's not going to produce, like I said, the same exact answer that we want, but it's very, very close to the solution. So here, let's talk about this one. You first want to see if you can make them the same base, can we?
Yes.
Yeah, what base can it be? 2. So this one's going to be a 2, and that one's going to be a 2. 2 to what power gets me 4? 2. And then I'm going to write in that black so that we know nothing changed, 3x. 2 to what power gets me 8? 3. Very good. I'm going to write in black what did not change. Good. Now we can drop the logs, get rid of them, and we can solve. Go ahead and solve this one. You guys got this. Okay, this is a review basically from yesterday. When you're done, only take a look up and see how you did. Walking around, I'm seeing that most of you got -1, so good job. Means you were understanding yesterday. Now let's talk about B. Can I, yes?
Plugging this in wouldn't make our argument.
So this one, we're not working with logs, so we're good. So only when we're working with logs, you want to check for extraneous solution, because in exponential, we can put any number into x. Remember, our domain is all real numbers. However, our domain of logs is 0 to infinity if it hasn't changed or reflected in any way. Okay, if it hasn't transformed. But our domain is restricted in terms of logs. But exponentials are good. Good question, though. Can I write 8 and 92 as a common base? No, you can't. So this would be a situation where you'd have to convert to log form, which we practiced a lot way back when. All right, here we go. So I have log base what? Log base 8 of 92 is equal to the m minus 7. Very good. I don't know why I just did a million colors, but we'll just go with it. Okay? So we just converted to log. That's all we did. You guys should be experts at this by now when you go back and forth. Some people like to use the heart. Log base 8 of 92 is equal to m minus 7. That's fine if you like the heart. Some of you put on your reasoning, use the heart method. Okay, that really doesn't mathematically, that's not mathematically. We understand what you mean by that, but if you told the mathematician to use the heart method, they'd have no idea what you're talking about. Okay, so you would just have to make sure that you're saying convert to log, which is what that mistake was on that quiz. All right, so now we can actually do this because we can do the change of base formula here. So go ahead and take a minute and do the change of base formula in your calculator for that left side of the equation. And that was just log of 92 divided by log of 8. I'm just going to write it out for the sake of notes. Some of you probably would have been able to just do that right in your calculator. So you're putting that left side into your calculator. Or if you have a fancy calculator, you could have just put what I highlighted in yellow. Either one. What did you get on the left side of the equation? Yeah, 2.17. I'm just going to go off to the side here. 2.17 is equal to m minus 7. Well, guess what? All we do is add 7 to both sides. And you get m is equal to, 9.17. Okay, you have to go ahead and check it. But look, the 9.17 is going to be going into the exponent part, which is okay. So we're good there. I'm going to square that off. Flip when you're ready. You guys are doing some pretty good math, some pretty advanced math, so give yourself credit. All right, cool beans. C, solve the equation using the common base formula if you need to. All right, so this is where people get a little stuck. You have to figure out where is your exponent. It's right there. Our exponential expression is right there in yellow. If it helps you, if you don't have a highlighter, box it so that maybe for the notes when you go back, you understand that we have to isolate it first. Well, just like we would solve anything else, what would I have to do first in the situation to isolate it? Yeah, subtract 1. Like, for example, some of you kind of have a hard time visualizing it. Don't write this down. But if I put 2x plus 1 right now, you're like, oh, we just subtract 1. It's the same thing. It's kind of like that piece is all together. You have to make sure that you get everything away from it. So I have 2 to 3, base 3 to the 5x power is equal to what? 54. Now what do I do? Yeah, I would bring the 2 over by dividing it because it's currently multiplying to it. And I get 3 to the 5th power times x is equal to 27. All right, now there are 2 ways you can do this. You can convert to log, or you can use the common bases. Which one do you want to do? Let's do common base. If you see that, then go ahead and do that. So I have 3 to the 5x power is equal to what? How do I rewrite 3 to the 3rd? Well, guess what? Goodbye. I get 5x equaling 3. Now you could have, if you did not realize that, you could have converted to log. That's the best part about these problems is that you could do it either way. It just depends on which one you're more comfortable with. And then I get x equals 3 over 5. Questions on that? So again, I'm just going to go off to the side here and show you what you could have done. You could have done log base 3 of 27 equals 5x. Either one works. You could have done that. All right, let's go ahead and do the next one. Can I write them as the same bases? No. Is it isolated? Yep, so let's go ahead and convert. How would I convert this? Log base what? Of is equal to? Very good. Solve that, please. And if you're getting stuck on how to put this in your calculator, please ask now. Now would be a good time. This piece is what you would put into the calculator. Don't mind my sloppy handwriting. When you're done and done only, please check. Always check my answers. Are you getting it? Are you getting stuck? Did I move too fast? Some of you, I can already tell, are flying through some of these problems. I want you to go ahead and try E. Remember, isolate the exponential expression first. That's this guy in red. He needs to be alone before, that's frozen. He needs to be alone before I do anything. If you try to convert right now, that's where you're going to go wrong. He needs to be alone. If I had x plus 8 right now, hopefully you would know what you would do. It's the same situation. Go ahead and try it. Again, if you need help, please let us know. Check your answers. Do you have questions on E that you'd like me to go over and how I got any piece of that? What I highlight needs to be in the calculator. That's what that is. All right. F should be super fun. Go ahead and do it because that's review. You have the same base. You don't have to do anything here. You have both of them with a base of 5. That should be like your favorite type of problem. So these should be gone. Go ahead and solve that.
This is so fun.
It should be fun. I love solving. I like math because there's always an answer. And there's always a way to check it. 98% of the time. It's not English where it's gray. We're black and white. Right or wrong. I didn't show the work, but you can check and see if you got it right if you finished F. All right. I want to make sure that we're getting it. You guys seem to be getting it, but let me just make sure that if there's any ones I really want to do. Let's go ahead and go to J, and then we'll call it a day. Okay, rhymed there. I didn't get that. So, a lot is going on right now. We see all these numbers. We're kind of like, where do we start? Some of you might already know what to do. The first step is to locate where the expression is. The exponential expression is right here in red. And like I said, for notes, if you like to just box that for yourself so that you know that that needs to be isolated before you do anything. Oop, that was supposed to be a highlighter. Okay, this piece needs to be alone before we can convert. One of the most common errors is not isolating it. People try to convert this right away. So what would I do to both sides first? Add 5 first. Don't divide. Add 5 first. Be careful with that. So I get negative 8, 2 to the x minus 9 power equals, because my mental math people, negative 72. See, basic math confuses me sometimes. All right, now what? Again, this is not isolated. If you want to keep boxing it so that until you figure out if it's isolated, then do that all the way down. If you don't need that, fine. What do I do to both sides? Divide by negative 8. Very good. Because it's currently multiplying to the box. Negative 8 is currently multiplying to my box, my exponential expression. So in order to do the inverse, I must divide. So I get 2 to the x minus 9 equals 9. See, just checking to see if you're paying attention. All right, now from here it should be okay because that exponential expression is alone. So let's go ahead and rewrite it. Log base of equals. All right, solve that for your homework. Oh my God. Whew.